So our next unit is the unit circle. We've got a couple of vocab for this section. The first is radian, and we looked at converting degrees to, we're going to look at converting degrees to radians. Radians are a unit of measurement that are based on the arc length of a circle. And then the unit circle is a circle centered at the origin on the coordinate plane, and it has a radius of 1. So our objective today, as I mentioned, to convert between degrees and radians. And then we're also going to evaluate trig functions for unit circle values, and we're going to focus on degrees today. And then the next unit, we're going to take a look at evaluating trig functions for radians. So first, converting between degrees and radians. What we need to understand about a radian, as I mentioned, is that if you take a look at a circle, and specifically the unit circle, so it has a radius of 1, the circumference is 2 pi r, and when the radius is 1, the circumference is 2 pi. Well, there are 360 degrees in the circle, so the exchange rate between degrees and radians is that 360 degrees equals 2 pi, or to simplify, we divide both sides by 2, we get 180 degrees equal pi radians. So we can use that relationship to convert. So if we have a negative 60 degree angle, we want our degrees to cancel. We would multiply by pi radians over 180 degrees. And then our degree units will cancel, leaving our units in radians. So we simplify, 60 over 180 simplifies to 1/3. So we have negative pi over 3 radians. So for B, we have 2 pi over 3 radians, and we want to convert to degrees. So we put our pi radians in the denominator, so those units will cancel. 180 in the numerator. So 180 divided by 3 is 60, times 2 is 120, and our pi's cancel. So we have 2 pi over 3 radians equals 120 degrees. All right, the special right triangles we looked at back towards the end of trimester 2, and they actually give us some exact unit circle values, so we're going to revisit them quickly. So just to remind you of that relationship, if we're looking at the legs of a 45, 45, 90, and the hypotenuse is 1, remember the generic 45, 45, 90 was x times the square root of 2. So I'm going to set my 1 equal to x times the square root of 2 to solve for the length of my 2 legs. So dividing both sides by the square root of 2 and then rationalizing, I get the square root of 2 over 2 is the length of each leg. For example 3, I'm looking at the legs of a 30, 90, 60 with a hypotenuse of 1. So remember, the short leg is across from the short angle. So if my hypotenuse is 1, and again to remind you of this relationship, we had x, 2x, x times the square root of 3, and that's why I put the angles out of order. Across from the 30 is x, across from the 90 is 2x, across from the 60 is x squared of 3, so you can kind of count in order. So we set this equal to 2x. Solving, we get 1/2 is the shorter side, and then we multiply that by the square root of 3 to get the longer side, and we're going to see all of these values, square root of 2 over 2, 1/2, square root of 3 over 2 in our unit circle, which is the next slide. So if you kind of take a moment to take this in, there's a lot of information on this unit circle, and you will need to pause and jot all of this down. Actually, don't do that. I will get blank unit circles for you to fill in. It'll be much easier, so just kind of take this in for now. And if you want some notes to look at for our last example, really all you need to memorize from the unit circle is the first quadrant. Because remember, in the last section, we looked at finding reference angles, and this is why, if you know the first quadrant of the unit circle, notice how this ordered pair, and I will explain what all these ordered pairs mean. are similar to this ordered pair, except for in the second quadrant, your x value is negative. So here's what all of these mean. The x coordinate for all of these ordered pairs is your sine, and the y coordinate is your cosine. So take a look, we've got this 30-degree angle right here. And if you think about that special right triangle that we just looked at, that 30, 90, 60, across from the 30 was 1/2, across from the 90 was 1, the hypotenuse, so look, if we draw in this right triangle right here, I just have mine oriented differently. So our hypotenuse is 1, or the radius of the unit circle is 1. And then across from the 60, we have the square root of 3/2. So if we look at the 30-degree angle, setting up the sine of 30, remember, SOHCAHTOA, opposite over hypotenuse, is 1/2 over 1, or 1/2. And the sine value is the y coordinate for our unit circle. So if we set up cosine of 30, SOHCAHTOA, adjacent over hypotenuse, well, square root of 3/2 divided by 1 is square root of 3/2, that's our cosine. And if you look, they've also got another nice pattern. Look at the numerators. I'm going to erase a little bit so we can take a look at another pattern. Really, all you have to do is count. 3, 2, 1. So the cosine values for the 30, 45, 60, those special right triangles we just looked at, go 3, 2, 1, and they're all over 2. And then the sine values are 1, 2, 3. All right, so let's take a look at evaluating. We're going to find exact values for some non-first quadrant angles. So we have to think about, first of all, finding the reference angle, and then thinking about counting 3, 2, 1, or 1, 2, 3. So for 330 degrees, again, I'm a visual learner, so I like to kind of jot down what exactly I'm looking at. It's positive, so I'm going to be spinning this way. 330 degrees. So I am 30 degrees shy of that x-axis. So I'm going to think about my reference angle is 30 degrees, and those are the ones that we just looked at. So sine, cosine, and then we'll talk about how to generate tangent as well. So sine was our y coordinate, and that one went in order, so that was 1, or 1/2. Cosine was the x coordinate, that one went backwards, 3, 2, 1, so that's square root of 3/2. But the 330 degree angle is in the fourth quadrant. So our x value is positive, but our y value is negative. So my sine is actually negative 1/2. And then tangent, I'm not sure if you have seen this relationship before, but tangent is sine over cosine. So we can generate tangent by doing negative 1/2 divided by square root of 3/2. And remember, when we divide fractions, we multiply by the reciprocal. So the 2's cancel, leaving us with negative 1 over the square root of 3. And when we rationalize that, we get negative square root of 3/3. And I will, in class, get you the unit circle as well as the tangent values, so you can memorize those as well. And the last example we're going to be looking at is 225 degrees. So again, I like to kind of sketch a picture. 225 is bigger than 180. By the way, I don't know if I've given you all of these reference angles. So this is how I figure out which quadrant I'm in, and then this is either 0, obviously, or 360. So as I'm rotating around, I know it's between 180 and 270. So there's my 225 degree angle. And then I think about where I am in relationship to the x-axis, because that gives me my reference angle. And it's 45 degrees past the x-axis. So thinking about my 45 degree angle, that's the one that came from the special right triangle that had the 2 legs that were congruent. So the sine and the cosine are equal, and those are both square root of 2/2. But think about which quadrant we're in. We're in the third quadrant, which means that both my sine and cosine, my x-coordinate and my y-coordinate, are both negative. And then my tangent This is going to be an easy one to figure out because I'm taking sine divided by cosine. But I'm dividing something by itself, which gives me 1. It's a positive 1 because the negative divided by the negative will cancel.